Today, on episode 2 of The Journey of Science, we sit down with our very first guest, Dr. Aswathy Ammothumkandy. She is a senior postdoctoral trainee in Michael Bonaguidi's stem cell laboratory at the University of Southern California. We chat about her latest work with human epileptic brain tissue and discuss everything from the current utility of animal models to cultural differences in laboratory environments around the world. Welcome, everyone, to The Journey of Science.
So how are you, Aswathy? And how are you doing?
I'm doing good, like happy with everything that's going on.
How are you doing?
I'm doing well. Summer is certainly in the middle of it.
It's so hot.
So hot. This is my third shirt today, and it's only 1 o'clock.
Seriously?
I've got I don't know, Gopu, about you, but I keep a spare spray deodorant around, just to travel deodorant, right? So if I walk into a building, I'm not smelling like sweat, but it's good. We've got I've got family in town right now, so it's a little chaotic at home, the in-laws, but so it's nice to be in the lab.
Oh my God.
So it's good to have them here, but it's also good to be able to escape for a little bit.
Have a break, yeah.
Have a break and recuperate and then re-energize.
Are you guys planning on any summer trip somewhere?
Aswathy?
I'm not, I have a little one who's 1.5 years old, so he gets sick. He recently started his daycare, so he keeps getting sick every now and then. So you can't really plan anything. If he's fine, then we'll just take the car and start driving. If not, just stay home.
Yeah.
Fair enough. I've been planning to go to Colorado. Oh, it's beautiful out there. Yeah.
That'd be good. Escape the heat. Yeah. So I got a question, Aswathy. You just had this beautiful paper, Nature Neuroscience. As an epilepsy biologist, both Gopu and I now, Gopu, I really appreciated what you did in terms of this human neurogenesis, human epilepsy. I mean, you took on human tissue. That's crazy to me. We've had some experience with it. We worked with certain neurosurgeons and they collect tissue, but can you just elaborate and explain to us what it's like working with human tissue, collecting human tissue, and the pressure and for me, it would be so it's one thing to work with a mouse when you've got 15 cages full of them, but it's so precious, right?
Yeah, that's so true. I don't take out the tissue, so it's the surgeon who's taking out the tissue. So I don't have to see that part. So we have great neurosurgeons who gives us the best. They take a lot of effort in giving us the best quality tissue. They don't have to really. They can just scoop out and just throw it, but they just scoop out it in a way that the tissue is as intact as possible, so that we can do live recording, cell culture, everything. So they do they take a lot of extra effort from their clinical responsibilities to make sure that we get the best quality of tissue. So so the main the initial part is done by them giving us the best quality tissue, and without that, I don't think we could do any of these things. And working with human tissue, as you said, it's very precious. Most of the times I feel the experiment itself is not difficult. It's just that, in your back of your mind, it's oh, this tissue is precious. I have to do justice to it. I can't fail. So that is in back of your mind, but I think with time you get good at it. So that has been difficult, you're oh my God, I can't waste this. I can't take and you can't do a lot of experiments because the tissue is limited. At times we are oh, we want to ask that, we want to ask this, but it's the tissue is only so much. So we have to prioritize what we want to ask, which is I feel it's good in some ways, because I find it that when you work in other models, in mouse, it's oh, let's ask this, let's ask that. And when you work in a Drosophila model, let's ask 100 things, because it's just, you have so many and you're let me ask everything. But here you have to prioritize your questions and to make sure. So I personally find it probably it's also me being a little lazy to ask a lot of questions and want to do only little things. So I like that part of it, that being able to prioritize my questions and finding out what I really want to look at and not just jump into the, like, I feel that if I would have been like given a cell culture, so I've worked in other cell lines, cancer cell lines and so on, they're like, it's like, you want to ask anything, you just go and do it. You don't think about it, whether it's going to work. But here you have to do a lot of, like, read a little bit more and think about it before you start to do it.
Yeah, you have to pre-plan a lot, don't you?
You have to pre-plan a lot.
Yeah.
But another problem that I find is, I wouldn't say it's a problem. Like, I feel like a lot of the things that we look at the human tissue is driven by things that we got to know from mouse models, like without knowing that these things would go wrong. For example, neurogenesis has gone wrong in mouse models of epilepsy. There is no way we are going to look at it in humans. But at the same time, I feel that our study has given us like some insights on what should be also looked at in mouse models, and probably there are better time for example, the importance of looking at chronic time points in epilepsy and things like those things. I feel we have given insights, but at the same time, some people are not. They're like, okay, it's just an association. You find an association. What does it mean? Like, you don't really do the mechanism, right? You can't, in a mouse models, you would go block it and see it. Yeah. Whereas here, most of our results are associations, which we do have plans to take into finding mechanisms, but it's going to be very incremental. So a lot of times I get this question that it's just an association. Does it even have any meaning?
But that's what you can do with the sample, right? You can't do it tracing with the baby.
Yeah, but it's like people who work in models are used to look at question like that, right? You have to address the mechanism. Without showing the cause and effect, you're not really addressing the question. It's mostly a correlation, and that's true. Like most of our results are correlation, making correlations based on what we see, associations made, and this has to be validated in mouse models. And I think that's what it opens up a lot more questions, which needs to be addressed in other model organisms. And I think if we didn't look at this, probably that it would have taken a lot more time for people who worked in mouse models to get to those questions. So I find it like a valuable piece, or that's what I feel like. Looking at human disease is important. Though you can't address all the mechanisms. Like I have this problem, like a lot of people keep asking me, oh, it's just an association, it's just an association. I'm like, okay, that association means something because you're looking at the human disease. And if that doesn't make any meaning for you, I don't know, like what is the point of addressing it in a mouse model alone, right? You have to look at every now and then, you have to go back and look at the relevance in a disease model, if that's your main question. If it's just a curiosity driven science, it's a different thing. But if you're trying to cure human diseases, then I think every now and then we have to go back and see if we are really asking the right questions.
Oh, that's interesting. You know, we get kind of the opposite criticism. It's like, you're studying this in a mouse. Like, why does that matter?
I know.
Yeah, exactly.
Right. I mean, I think especially in the epilepsy field, there's so many differences between mouse models of epilepsy and all just human clinical epilepsies. They're so diverse in terms of how they can present. It's interesting hearing you say, here's a really critical human study. We need to go back to the mouse.
You see, right? So that's what I'm saying. Like, I don't think that criticism is valid, that it's just a mouse model, because as you mentioned, we have very little bit of tissue, and there are very little questions that we can ask. And that is driven by answers that we know from mouse. If we didn't know that, what would we look at? We're going to ask 100 things, which doesn't make any sense. So
that's great. Yeah. So it's like you're fine tuning what you're going to study in the mouse. Like, ignore this other stuff. It may be there, but really what's this is the important part that's relative to human pathology. Oh, that's fun. So how was it?
I just want to finish it. I'm not saying that the other part is not important. I feel that a lot of times, by the time the patients come to the clinic, it's like this late stage of disease, and the disease progresses very differently at the chronic phases versus early phases. Whereas in mouse models, people always tend to study early phase. One, probably it's much relatively easier because you don't have to age the mice all this time and develop, it's just easier to look at. But probably the other one has, clinically, by the time the patient is in the clinic, and it's already the disease is there. So I'm not saying that you shouldn't look at what causes the disease, but there should be equal weightage given on, like, when you know there is a disease, what can you do about it?
So what was it like? Did you work with a lot of the neurosurgeons?
Yes, we do have like meetings with our neurosurgeons every 2 weeks. We do try to prioritize what our questions are.
Mhm.
Apart from us, there are other collaborators. So they try to look at who needs tissue for what experiments, and they try to give us. So most of it has been interactions during meetings where we prioritize our questions, and then it has been like, yeah, I don't have to walk into a surgery room if that's what you're like, have you like, yeah. So usually they.
No, I just know a lot of these procedures are at like 5 a.m. Right?
Yeah.
So do you get a phone call like, hey, tomorrow, 5 o'clock, be there tomorrow morning with your bucket of ice or something?
So it's mostly night. They start around 7 o'clock in the morning, but depending on how the other surgeries go, it gets delayed. And so usually I'm in the lab since like starting from 9 o'clock in the morning, but probably by the time I get the tissue, it's probably 9 in the night or.
Yeah.
So it's a long wait because you can't.
And when you get the tissues, you have to do all the recordings immediately, right?
Yes. I don't do the recording experiments. It's done by Victoria. So she has to stay overnight and do.
Ooh.
My experiments have been mostly cell culture, which finishes in 2 to 3 hours. So I can go home in 2 3 hours, but Victoria does a lot of overnight experiments, staying with the tissue. And like, it's like, again, you have the precious tissue, you want to make best use of it. So she stays overnight and gets whatever is possible.
Well, that's a nice system then. It works out. It's great that you have clinical faculty that are so interested in research and engaging with the research done there, right? I think that's a huge, hurdle for a lot of folks that work even with access to those neurosurgeons, is you just don't have a lot of neurosurgeons that care to take the time. They can just hand you a clump of brain tissue and say, here's the hippocampus, and you're like, well, what am I looking at? Right.
Yeah, I think they had this collaboration for a while, but Michael, like the lab that I'm from, Michael actually initiated this collaboration and actually strengthened this program very much, that like we have great research going on. Like, even as a follow-up of the study, we have other like very like research that can go into translational ways.
Yeah. So how long did this whole thing take?
Yeah, that was my question.
So I joined in 2017. So it's like 5 years now. So that was the time Michael started. So I actually started this project. So Michael had already plans of what needs to be done. But I joined in 2017. And
so he had just started the lab right when you joined?
He had already, it was already 2 years. His lab mainly focuses on neurogenesis, particularly using mouse models. We also had another postdoc who was working on Drosophila models. So he actually liked integrating all these, multiple models, because each of it has its own benefits, right? You can't say that like the Drosophila model gives you a lot of high throughput. So he actually wanted to build this. So I think he probably hired me because I had experience working with human tissue, not the human brain tissue. Yeah. And I think the reason for hiring me was probably he wanted someone who was willing to work in this odd hours, like 9 o'clock in the night, to work with the human tissue. Yeah, probably.
So where did you come from? What was the system you worked on?
I previously worked on human cervical cancer. It has nothing to do with human brain. So that was a huge transition for me.
And why did you decide to change? And why US of all the countries?
I think, why did I decide to change? I think I always wanted to work on neuroscience. Before for my PhD interview, my whole interview was with a panel of neuroscience, because I said I wanted to do a PhD in neuroscience. But what happened was, the institute that I joined, they did not have faculty who were working on human disease model. And I was like, I want to work on human disease. And also, it's not just that, I also had fear of working with mice. So I'm really scared to work with mice.
Even now?
Even now, I'm very scared of working with mice. So I didn't want to work on. So I would say that my first rotation was in a lab that worked on hippocampus using mouse models and rat models, and they were like, that was the lab I wanted to join. But then I realized I'm not capable of handling a mice. I don't want to do this. And then I canceled all my other rotations, which were again in like amygdala and things like that, which again was on mouse models. I was like, no, I want to work on someone who works on human tissue and not mouse models. So I ended up joining a lab that worked on human cervical cancer, because they worked on human cancer biopsies.
And after PhD, you take any break, or was it just PhD adjusted then postdoc?
No, then it was immediately postdoc. I was like, this is my one shot to again go back into neuroscience. And I was like, let me give all my effort. It was really difficult to do that because everyone was looking for like experienced people who had the experience. So it was tough to change, but I really wanted to change. So I changed.
So you moved from India to US, right?
Yes.
How was the cultural change?
There are a lot of pros and cons, right? When you move to a different country, I think the biggest problem is you suddenly hit with this loneliness, because I moved alone. When I moved here, I moved alone. My husband joined me like 9 months later. So the first 9 months I was here alone. So that was a huge thing. I was like so homesick. So that was one thing which did not let me enjoy a lot of things in US the first year. But I would say once my husband came here, I started seeing the positive things. Like, there are cultural differences, but what I really appreciate about the thing here is I think most of the people who do any kind of work, everyone enjoy their work. That is something which I found, I don't know about like how it works in other countries because I haven't spent much time in other countries. But compared to India, I found most of the people, they enjoy what they do. At least they seem to enjoy. Outside, they seem to enjoy. Even if you walk into a coffee shop, they try to have a conversation with you. They are very positive about talking to you. At least they do talk. You really don't know whether they really enjoy their job, but at least outside, they seem to really do it with so much of passion.
And what are the things that you don't like?
Things which I don't like, I would say, again, the same thing. Probably it's a little bit superficial, and probably they don't connect a lot beyond that. So for example, in a lab in India, students are more tightly knit together. They have an emotional connection. Here, I think there are clear lines between personal and professional.
Oh, definitely.
So you don't interfere. I don't know, is it because I am an Indian? You probably get along well with from your people from your own country. So maybe that is a difference. But even between to Americans, I've found that they try to there is some
That's a very strong line, right?
There is a strong line.
I observe the same thing too, because in India, your colleagues are basically your friends and your family.
Family, yeah. Here,
it's a very community-based thing, and here everything starts and ends. Like starts at 9, ends at 5. After that, there is no communication, no nothing, and the cycle repeats again the next day. And one thing I found when I moved to US was everybody was so loud. You have to be so loud. Yeah, it was some change for me too.
So I imagine that makes it more difficult coming to the US for the first time, trying to integrating into some social network.
Oh, yes.
Find friends. Right. I mean, if everybody's clocking out at 5 o'clock and then you don't interact with them outside of the lab, that makes it difficult.
True. But I think it's not even in professional places. I think even in personal spaces, Americans tend to have strong lines between parents and children. Like in India, you don't have parents have all say on your life.
That is a good thing or a bad thing.
So I'm saying I don't know if it's good in some ways and bad in some. Like in India, everyone interferes in everyone else's business. So you don't have that. So it has its own positive note and negative things about it. So yeah, probably we have to find a perfect balance. So
yeah, it's so true. When I finished my bachelor's and master's in India, and for my PhD I went to Japan for 5 years, and there it was even more strict. The social things were very strict, but then very Asian, you have to respect your like professors and your scientists, that respect factor was very big in Japan, and so was in India. Like you would
Yes.
never call your PI by name. That was just like, oh no, 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 that's a big no. And here when Jenny said, oh, just call me Jenny, it's like, are you sure? It's like it took me a month to exercise like the muscle memory. Like, oh Jenny, okay, I can't call you professor or madam or sir, Jenny. It was something.
Yeah, that's also good and bad in a lot of ways, right?
So
Yeah.
when you're homesick, what do you look for? Is that like, do you go to food? Are there TV
Now
shows or anything?
now I'm not homesick. Yeah, I do get homesick because I just have my husband and son alone. But yeah, probably now it's not bad. In the beginning, it was bad because it was all alone. At that time, all you can do is eat food, binge watch Netflix series. That's all you could do.
Because if you're in LA, they've got to have a pretty good assortment of restaurants and Indian
They
food.
do. They do have a lot of Indian.
How would you rate it in terms of quality or experience?
I would say it's really good. I didn't expect to get such good Indian food, and especially I've heard from my other friends who live in other states that they don't get so much variety in Indian food over there. So I'm glad I'm at least in LA where there is option to go buy Indian food, eat, and like groceries, everything. Yeah.
What about San Antonio, Gopu?
Oh, it's amazing. I was surprised. It's the Indian community is very strong. I mean, I'm not close to them, but then the restaurants, the culture here, the food is very authentic. That's what it surprised me. The level of authenticity. It's like, wow, that was surprising. Yeah. What's the postdoc life like in? You said LA, no? I'm sorry, I forgot. Right? You live in LA. So what's postdoc life like in the sense like the cost of living and the general quality of life there? Or is it just everything consumed by the lab?
I wouldn't say so. Like I don't know. I've heard this from other people that there is a huge difference in the work culture in East versus West Coast. In West Coast, it's more cool and chill, and in East Coast, it's like people work late nights, weekends, everything. So here, at least that's what I've seen in my lab. People work when they have work. So there are times when you have to work late night, and there are times when you can leave early. So you can decide. At least I think it's a lot driven by the lab culture. Also, I would say like what the culture the PI cultivates in the lab. There are other labs that I know in LA where people don't have that flexibility. They have to doesn't matter, they don't have any experiment, they still have to be in the lab and wait for a boss to leave, though they are simply probably looking at the Instagram or something like that. But I think it's a culture, I believe, and at least what I've heard is LA has a more cool lab life. I don't know if that's true. I think it's mostly PI, the culture that PI cultivates, I believe.
It makes me think of one story in Japan. So one of the professors I rotated, that person had a rule like by 8:30 everyone should be there in the lab. Like, okay, fine, cool, whatever. Then I went to the lab once, and the professor called me to their office, and the professor was like, oh, you are such a disappointment to me, and you don't respect anyone. And he was just like blasting me. Like, what happened? Are you kidding? It's too early in the morning for this. What happened? And he said, oh, you don't respect anyone in the lab. You come to the lab so late. I told him, no, I came on time. And the professor was like, no, you were supposed to be here by 8:30. You are here on 8:32. It's like, you know what, bye. Thank you very much for your service. Bye.
Yeah, so I think it's PI. I don't know, like, are all labs in Japan having a heavy work culture? Like, usually Asian countries have, like, people in Asia are more hardworking. I've heard that they tend to work a lot. So is that the culture that...
More or less, I would say. It's very, I mean, what I felt like their identity was very much connected to their work they do. Okay. So they tend to sometimes overdo things.
Yeah.
And it's, it can go in all different tangents.
So true.
So what is next for Aswathy? Like, are you looking for PI? Like, are you looking for professorships? Are you joining for industry? What's next for Aswathy?
I want to be a PI. That's my dream. Like, let's see how it goes. I hope to apply this year. So, like, hoping to get some good position by the end of next year. I don't have a backup plan. That's my problem. Because I think I've so focused on doing research, I haven't thought about, and I have no experience in working in industry, and it feel like I'm a little bit scared about entering even into industry. I'm like, I probably don't even want to enter into that field.
Why?
So it's probably I'm gonna give my best shot for becoming a faculty right now.
Hey, sometimes not having a backup plan is the ultimate motivator, right?
Yeah, right.
I don't have a net to catch myself. I've got to do or die. So
yes, it's same like I said. I don't want to work on mice. Everyone was like, everyone works on mice. How can you say you won't work on mice?
yeah, I said I wasn't going to work on mice, and I still work on mice.
You did say that.
I did say that, but
You work with worms, no, Zane?
Sorry.
no. I did work on worms, but I don't anymore.
Why did you not want to work on mice, and why do you now work on mice?
It's just one of those things that, like, you work on them, they're such a pain. You're like, I can't.
Okay.
I'm just tired of it. I want something fresh. But then, like you said, there's a utility to everything, and as projects grow and you understand their utility, they just find their way of coming back in. It's a tool set, and it's there. So
it's a valuable tool. I remember I had a conversation with Michael once. He was like, now that you're going to start looking for faculty position, do you want to start working on mouse models? So you have to be independent from your PI and have a different project, right? So one way you could make your own mark is like, here you looked at human and now you can look at mouse. So he asked me, now you are not going to be working on mouse models. Are you interested? But I was like, I probably don't even want to work. I realized that, like, after working on human tissue for a long time, I realized that it's not even fear anymore. I feel that I do want to work on human tissue.
So are you going to continue this line of work, or is that going to stay in the Bonaguidi lab? So
Michael is definitely going to continue this project, but
because it seems like it's so integrated, like they have the network and the system there. It'd be very difficult to do and to set up outside of that. I mean, it's very...
Yes, and it's so well established now, and we have translational projects. So he's definitely going to continue this project, but like there are aspects of the project. For example, we ended up finding a glial cell which we didn't look for. So that's the part of the project that I'm going to take forward, because I told you, right, Michael works on his lab. The broad focus is on understanding neurogenesis and the possibilities of regeneration and so on. So I'm going to focus more on the glial part of the story. So, yeah.
Fantastic.
Still in human tissue.
Still.
I have to ask you one question. So this wonderful paper, what are the part of the experiment that didn't work?
Didn't work. I think a lot of things, it was like things which didn't work in the way we thought. In the beginning, it was like, we'll end up finding a lot of aberrant new neurons. All the mouse experiments say that there is a ton of aberrant neurogenesis. So probably we're going to find a lot of newborn neurons everywhere. And we looked at it and there were no new neurons. I was like, shit. Now, what are we going to study? We had this huge hypothesis. Okay, it's the new neurons. They have a lower threshold for getting active, and probably that's what leads to the hyperexcitation, neuronal hyperactivity. And now you don't find new neurons. I'm like, what is your hypothesis failed completely? Now you don't have it. No, now what is it? So that was the thing. I wouldn't say things which didn't work. It was a lot of troubleshooting. Staining didn't work a lot. Cell culture didn't work. We had to do a lot of troubleshooting to find things which ultimately worked. And there are aspects which, we wanted to keep it longer, which we are not able to. There are, we wish to culture them much longer, but after a certain point, they fail. And we wish to culture every tissue that we get, but that's not the case. We can't culture every tissue. So those things don't come into the paper, right? How, what is your success rate and things like that. Out of like probably 20 tissues that you culture, probably it's only 7 or 8 that grow. So there is a lot of like like things that don't come into paper, which I think probably all of it should go into the paper, so that people who start doing don't get disappointed when things don't work for them. Like, okay, it's not all good.
Sunshine.
Yeah. Yeah. So it was like another thing which was like, we started looking at DCX, a marker for newborn neurons. So since mouse neurogenesis field, DCX is very much a marker for newborn neurons. We were like, when we found it everywhere, we were like, okay, something is wrong. When we started at co-expressing with glial marker, I remember Michael first time even like, it's like, you probably messed up the antibody.
Oh, that would have been my first thought.
Oh, yeah.
Like, what did I mess up?
I didn't know, because, since I was not from neuroscience background, a lot of things were like, I didn't know what to look for.
Sure.
So I didn't have a lot of disappointment.
Well, that's refreshing, because you're kind of like, what do you mean this shouldn't be this way? This looks great to me, right?
Exactly. It looks good to me. That's so true. Yeah.
But I think that goes back to what you're originally saying, is like, we've pushed mouse models so much. We've defined what we think this disease looks like based on a mouse brain. But a mouse brain is not a human brain, right? That's just the honest truth. And if you've got double cortin co-expressing with TUJ1, maybe that's the norm. That we're just, maybe that's a norm for humans that is not the same for whatever reason in mice, and we have to reevaluate how we define the disease. I mean, that's
exactly.
What do you think about organoids? Because the thing is, like you both were saying, like you didn't want to work with mouse.
Mm-hmm.
For me, I'm so comfortable in working with mouse. Mouse is just my bread and butter. I do not even want to look at cell culture. Like if I look at a culture plate, that will get contaminated. It's like, I'm just so bad at it. And when people do organoid work, I'm just like, I get it, I appreciate you, but then that's not my cup of tea. I just do not want to do that. Like, do you plan to incorporate that into your lab?
So in the very beginning, like when I joined Michael's lab, we had 2 projects. One was on iPSC models of hippocampal neurons, generating hippocampal neurons. This was in collaboration with another lab, Ruchi Pachpai. So we had these 2 projects, and this was like more like my, like gonna be my main project, the iPSC one. And this was like, high risk project. Probably it won't work. Getting human tissue, we don't know how many tissue we'll get, whatever phenotype we get, we don't know if we can see it in enough patients. So this was my main project. But with time, this kept on, like, the human actual tissue project, disease project we got exciting results, and we were like, I also tended, probably Michael also, in a way, it was all like one got more exciting and the other one didn't go that well. And I think pandemic also had a role in it. I had these iPSC cultures, which I was trying to grow from a genetic model of epilepsy, SEN8 mutation one. And the pandemic happened. The time when I thought, okay, the project is probably going to grow, we had to close it down. We had to shut down through cultures. But then the other project took in new directions. There was this whole aspect of like analyzing human cognition data in association with neurogenesis, which we didn't have enough time to look at it before, because of, you have experiments at lab and you have to do it, and you don't have time to go and sit and analyze these neuropsychology data. But then sitting at home, what do you do? So like there was an undergrad who was working with me, who was supposed to actually do this iPSC project full time. He was a CERM undergrad, the California Institute of Regenerative Medicine undergrad program. They get a chance to work in the lab 1 full year. So I thought that probably he can actually start working on this project extensively during that year, and the lab closed. But then he started working on the cognition aspect, which now we have really like exciting results showing association with neurogenesis. So some of it was changed by pandemic, some of it probably our own bias, as you said.
During the pandemic, the lab completely shut down?
We shut down by mid-March, probably, but I think August, September, that was the time slowly people started coming in more regularly. I had some human surgical tissue cultures, which I got permission from the department to keep it, like go in lab for half an hour once or twice a week to keep them. But anything that could be recreate, like, iPSC culture, you can again thaw the cells, you can again put the promoter, you can do all these things again. So they didn't give us permission to do that. Whereas we told we can't go and operate another human brain again and get this tissue back. So there were aspects which were running, things which we had to throw away.
So how long can you keep these cultures going? You said there's a finite period of time.
Yes, so it's just 2 or 3 passages, that's all. And after that, they really don't grow after that.
So this is, you dissociate the slice and then you kind of select for the progenitors, and then
so
they
it's
grow
a neurostem cell
the neurospheres. Okay.
But neurosphere cultures, no?
Yeah, so it's not as robust as a mouse neurosphere culture. Our lab also works on mouse neurospheres, and they are really robust. They grow like anything. Here, it's like in a 24 well dish, one well, you would probably get like 50 to 100 spheres, whereas in a mouse culture, you would get the same number of seeds, you would probably get 400, 500 spheres. So, and that expands robustly with time, but here that's not the case.
So but for the MEA, you just took the slice, right? Could that does that survive just a couple days or?
No, most of the recording experiments are done overnight. So we start by evening, 6 o'clock, 9 o'clock. Till morning, 6 o'clock, you could probably record. With time, you'll see. That's all.
So then you just get rid of it after the recording?
No, we actually stained the same tissue after recording. We subsectioned the same slice to make associations with where did we find activity in regions where we find neuronal hyperactivity, what is going wrong differently, and things like that. So we stained them after that.
Yeah, I'm just curious what, when you cut it out, you're essentially injuring the tissue. I've always just been curious, like, how is that, we treat that as if it's normal brain tissue or disease, but it's, this is what happens in the brain, but we're also introducing a pretty severe injury to it. I was just always curious, like, how does that work in terms of how that changes, which is almost technically, how are we ever going to determine that? Right?
Yeah, I don't know how are we ever, that's a question we always get asked. Do you know if your cut itself actually caused this gliogenesis? But I'm like, probably that cut wouldn't have enough time to cause so many but there might be like changes in inflammatory signals and so on that might have happened because of the cut. You can't, I don't know what is a way to.
And your control tissue was post-mortem?
It was post-mortem.
Yeah,
we didn't in the beginning have post-mortem tissue. Like when we first submitted the paper, then the reviewer was like, you should.
Oh man, okay.
The reason was because, the post-mortem tissue is analyzed, processed very differently. And depending on that, your staining looks very different. And it does look. So in our paper, we had refused to do any quantitative comparisons between all our associations that we make with the control are more qualitative than quantitative, because we know that the staining looks way more beautiful in a live tissue than a post, way more beautiful in a live tissue. That would have a huge effect.
How long did the revision process take for the paper?
The revision process, I think we got back after first submission in beginning of 2020, January. New Year Day, probably something like that. Beginning of the year, your paper got rejected and you're ready to revise it, and then the lab gets closed. Then you don't have epilepsy surgeries because these are elective surgeries. They did not happen for a really long time. So
that's true.
So 2020, 2021,
Oh, wow, that's a long time.
That's a long time. Probably some of it was because of pandemic.
Makes sense. Oof.
But we had tissue that we had saved for some of for questions we thought the reviewers would ask, so we could go back. We didn't get a lot of tissue during pandemic.
I see. Okay. So how was in the place you work, how collaborative is the place? Do you have collaboration with the nearby labs, or it's, how what is the support system like in where you work?
The department that we work, it's very collaborative, and it mostly depends on the kind of your research. So generally in my lab, one of the major strengths that Michael has is basically the bioinformatics strengths that he has. Like, he's really good at analyzing single cell data. He has PhD students who are really good at it. So he collaborates with other labs for the single cell sequencing and analysis aspect. So most of his collaborations with other lab has been for that particular part, like doing sequencing and analysis. And then this clinical collaboration. It depends a lot between labs. Again, I would say there are labs where they don't do a lot of collaborations and they are more into their own. It's mostly, I think, again, the choice that PI makes, whether you want to be more collaborative versus not.
Well, some of these things you have to, right? With this type of project, especially, you've got to be.
You have to.
Integrated. Yeah. It almost feels like the way science is moving forward. It's, to survive, you have to bring in so many different parts that are outside of your expertise. There's no way you can't network. You can't survive without collaborating. And
it's also like, if you think about any big paper, they want, right now single cell has become a common in basically any paper that you read. Single cell, they want data from cell culture, they want mouse experiment, they want human experiment. All these would be one figure. And I'm not even talking about the supplementary figure. So a single person, it's impossible.
It's impossible, yeah.
All this. Yeah, it's like, oof, it's rough.
But it's also fun. I find myself the most creative when I'm working with people in areas that I'm not familiar with. They bring something that's fresh. And that really, for me, I found work really stimulates the creative ideas, and those end up being the fun ones, right? There's always, I have projects in my lab where I'm just like, oh, this one's so boring.
This is again the routine stuff.
Like, can somebody just let this thing die so I don't have to deal with it anymore? But it's like, it keeps moving forward very slowly, and you're just hoping one day something lights up and it's interesting. But and then there's other projects that come out of interactions with, I work with a lot of engineers, and so it's just working with them, and I'm just like, this is what I stay up at night thinking about is how to get this one done. And I wouldn't have any way to do it on my own. I would not have. So I'm a big fan of collaborating.
That's also a benefit of academia, particularly, right? That's what that's my fear of going into industry. In industry, you don't have if you find something interesting, can you just go and tell the people who are above you, I want to address this question? They're we don't have money. So
yeah, that's a good point.
That's my fear of entering industry. You can't really address those exciting things. Like, something new comes up, probably no. You don't have that, flexibility. I don't know. I haven't worked. That's what at least I see from outside.
So are you looking to stay in the US? Are you casting that net internationally, globally, locally?
This year, I'm going to really look at applying. I think this fall is when I really look forward to apply. And it's mostly going to be labs in US. And then probably, I said, I don't have a backup plan right now. Probably next year, depending on how successful my application process is. No backup plans as of now. It's going to be a lab in US.
You got it. You got it.
I don't know. Gopu, you have experience working in Japan. I don't know. And you asked me in the very beginning, probably I didn't give you an answer for it. Why US? I don't know. I think one reason I like to be in US is the language itself. Europe is, I've heard that it's more fun. You can have a much more exciting work-life balance. But I'm I won't know the language. If I don't know the language, how would I fit in? So unless I'm willing to learn a new language.
It was the same for me too, because I was near Tokyo for 5 years. And then, I was lucky because I was in an international city and everybody could speak English. But then there was a point where I thought of learning Japanese, but then I was doing PhD and it was so, I had a choice. Either I could spend some time learning Japanese, or I could do 2 or 3 more experiments. You know? So then after that, all my friends spoke Japanese, so it was easy. But then still, I wanted to be somewhere where I could speak language and it would be much easier. Then my options were UK and US. Then I thought, people say many things about US, and I was just more curious about it. And it is that time that the whole political drama too was happening. So I'm just like, what is about that place? I'm curious about it. But I have a question for both of you. It's like both of you have family, and I just got engaged. So before when I was single, I had all the luxury of time to do whatever I want to do. And after this, now I'm a night person. I love working in the night. But then now my priorities are slightly changing, because if I go home late, there'll be him sulking and like showing me all kinds of faces. I'm just like, no, I have to go back. And so how do you balance all this? Both of you having big paper. How did you do it?
Zane, do you want to take it? Or?
Sure. Gopu changes. Just embrace it. Congratulations on the engagement. But it was actually, I think it was a very positive. I got married and started my family halfway through postdoc. So I have 2 kids right now. Young kids, right? So that it's definitely a lot of work, and my recreational free time is very structured, basically because it's, when I'm at home, it's family time, and I spend a lot of time, especially as a postdoc, putting up those boundaries. I mean, maybe you guys talked about cultural differences and boundaries. I mean, this was a huge deal. I had multiple therapists on board helping me separating work from like home stuff, and it was a big deal just for my own mental health, and it helped tremendously. I was way more productive in the lab, I think, once I kind of got this done. COVID then came and just destroyed it all. So that was a little bit of a backpedal, but it's more energy to balance everything. But I've also found things are moving forward a little bit better and faster once you've kind of got it. It sets priorities. So you say, this experiment, I don't have time to waste poking around with it. I've got to do X, Y, and Z. X, Y, and Z has to get done by this date. And if that's just no plan B. That's just it.
Yeah, that's the thing. When I was single, I had the luxury to, as you were saying, poke around and see some things. And now it's like, nope.
It's fun. I loved it. And it's great. And you learn a lot that way. And I think it's so critical, especially as for an early career scientist, to have that luxury just to really get a good sense of themselves as a scientist.
Yeah.
But when it comes down to work, you got to switch gears, and you got to focus on productivity and how to make yourself the most productive. And I don't think there's a single key. Some people seem to have a magic answer. To me, it's an everyday effort. So, what about you, Aswathy? You said you've got a small one too.
Yes. So for me, I think the beginning, like getting married, was not the part where I struggled, because I got married to one of my lab mates. So we were doing PhD in the same lab. So he understood the problems that people have in a lab environment, what needs to be addressed, what are your priorities. I didn't have to explain that bit to my partner. So I was given that option to, it was like when the partner understands. So it was easy for me, I would say, like when I got married. But I think once you have a child, then your priorities change, right? Then it's like you have the small human, like whom you have to take care. They are dependent on you, and it's a very important time of their life, which is very critical. So you have to spend time for them. Like there is no other way. So it has been, like, again, this was the first time in life I had to think about how do I do. Till the time I had baby, I never had to think like work-life balance. It was like, uh, I enjoyed working. So working was never like, yeah, at times it's exhausting, but it was good. I was excited about it, but I didn't have the struggle to, but now I do. Like, I am a person who never usually say no to people. Anyone asks me to, I'm like, yeah, I'll do it. I'm like, now I'm like at a stage in my life that I'm like, it was so difficult in the beginning that I had to cancel a meeting. Like, how can I, like,
God,
if I'm sick and you're like, I have to cancel, I don't have a choice. But I think, when things come up, you learn that, oh, you can say no if something else is more important.
And I would say that's also a bit cultural, because in India and in Japan, you just say yes to everything. You say
Yes to everything.
somebody asks something, you just say yes. And here, when I have to say no to some of my undergrad mentees or anyone, like I would have a stone face and I would can say no. And when they turn back, I'm like, oh my god, I just said no. I feel so bad for saying no.
Yeah, I have the same problem. Like, I'm like, once I can't even say no, and like once I say no, it hurt. Like, I feel so guilty about it. Like, why did I not help that person?
Do you feel like you've got a strong family support system nearby, Aswathy?
Again, like, because like it was pandemic, it was difficult in the beginning. Then my in-laws came in here, so they helped a lot.
Okay.
Like, for almost a year they were here. So now he's started daycare. So yeah, so it's all working now. As you said, after a point you learn how, like, in the beginning it's all difficult. Like, you're all alone, you're trying to handle, and then once you try to handle, then people come and then everything messes up. And then you're like, again, you are all alone again. Now it's everything changing. Now I think I found a balance of like how to make things work. And once you find that balance, as you said, it's more like, good in a lot of ways, because as you said some time back, Gopu, like, most of the times it's not all sunshine in science. So the only sunshine you have is this family, right? So having that family to go back is great, because in science, most of the time you have.
Do you feel as a woman postdoc, you're supported just by the system? I think that's a huge deal that a lot of people are openly discussing right now, is not just the support of postdocs, but especially for postdocs that are starting families. And
I think it's quite supportive, but again, like, the biology is in such a way that, you are still, it's like, my husband is very supportive at home. In lab, my PI is very supportive. So I do get that support system from the lab and from home. But at the same time, this is a part of like time of my career where I would like to go network. I'm not good at networking a lot. I'm a very like, introverted person, so I'm not good at it. But I was like, this is the time I have to do it. If I have to find a job, I need to like talk to people, find where do I fit in, to get to know what is there. And my PI was willing to send me for a lot of conferences, but there are a lot of times I have to say no because of family obligations. And it's like, a child, as they grow, like, they tend to bond much more with mom a little bit, that's their, my son like loves playing with my husband, but at the same time, I am his, in the night he needs me. Yep. So it's like, that's just, I think the way the biology is, the mom is that, person where the child feels safe. So I can't change it. So, and I don't want to change it. But at the same time, I can't go to conferences. Probably, I think if I was a man, I would have been easily been able to go to conferences. Yeah. And I don't think it's because of the lack of support system. There is, probably if conference centers had places where they handle childcare centers and things like that, it would have been easy to, like, difficult to travel with a child all alone. But now everywhere I go, I have to take my family with me. I travel with my husband. And so he has to take leave from his workplace. So that's inconvenient. A child's, circadian clock is very, rigid, and it messes up. So it's a lot more. The support system is there, but
it's not enough.
Right? I feel like that bringing equality for men and women, it's not that easy, even with the support system. It's so.
I definitely sense there's change. There's definitely there's a lot of talk about it, and
Yes.
I think especially with younger junior faculty, it's a lot more accepting.
Yes.
I mean, I say that I work at a women's university, so the culture is absolutely different here than it is anywhere else I've worked, for the better in terms of a lot of those support things. But I also just see, people being very vocal about like, we need to be better at doing these things. And I expect there's change moving.
There is change.
I think there's definitely. I mean, even before COVID, we go to these conferences and there's kids running around in these talks, right? And it's just going to have to be something like that, right? Just because you can't take a week off. Like, no, I mean, I can't even take 2 days off, really.
Yeah.
Right. And put that amount of work onto my partner. It's just something that I think in academia, we should have the luxury to do some of those things too. So
yeah, I think that is also something good about academia, right? In industry, you don't have that, flexibility, right? You have to work 9 to 5. And if you're not there, you have to take a leave. Then you run out of leaves, sick leaves and things like that. Whereas in academia, you can go you can balance with your partner to do experiments probably in a later time of the day and things like that. You can work that out in academia, which you don't get that flexibility in other fields, right? At least in industry, the flexibility.
So is your husband also still in science?
My husband is also still doing postdoc. So yeah, so both of us have that flexibility now.
So when you're now thinking about the transition, right? You've got to consider it's a 2-body now.
It's a 2-body problem, yes. And we are at different stages of our career because, I told you, I started 1 year before him. So we are at different phases. And there are a lot of things which come into play because of visa issues, because we are not from America. So there are other things that your visa runs out, you have to be a different visa. So that's probably a whole thing you don't even want to hear about. So
save that for volume.
You have 2-body problem, then you have the visa problems, and
yeah.
Oh wow, it's a lot. But then good luck.
Yeah.
Good luck for all.
Thank you so much. Yeah.
And final thing, since we both are Malayalis, I think we should teach Zain a Malayalam word.
Yes. Oh, please.
Right?
Yeah, absolutely. What's a good one?
What's a good one? That's a
Sugamano.
Sugamano. So Sughamano means how are you?
Say that. So spell it again.
SUG. I'm actually writing down SUGHAMANO. Sugamano.
Sugamano.
Oh yeah, quite good.
What does that mean? Hello.
How are you?
How are you?
And basically, it's are you well?
Are you doing good? Yeah.
That's awesome.
And you can just say Sukham, SUGHAM. Sukham means I'm fine.
Sukha. Okay.
And another word is Adipoli. ADIPOLI. Adipoli means fantastic.
That's a fun.
In a very not formal way, of course.
Sane is what have I called it?
No, that's great. Sukamano.
Yeah.
Sane, do you know any other languages apart from English?
Oh yeah, I live in Texas, so grew up learning Spanish.
Okay.
I have family that lives in Germany, so I've been
know a little bit of
learning some German. So
okay.
But I would not consider myself fluent in those. I know them. I could read them, but I can't at all. I would be timid to have a conversation with somebody. So
what language do you know, Shruti?
I know Malayalam. I think I can understand Tamil. I can speak well in Hindi with grammatical mistakes and gender mistakes. And I think I can like English. So 4 languages.
Yeah, I would say it's the same thing. Malayalam, Tamil, English, and Hindi.
Yeah.
Yeah. I think that's the thing, in India, you just have to learn all these languages, else you can't just live.
Yes.
Anyway, that was a wonderful talk. Thank you so
Yeah,
much.
I really enjoyed
Thank you.
yeah, it was fun just, chatting about science, how life is.
And we
Well, thank you so much.
best.
Yeah, I had one question to you, Sane.
Sure.
What is your piece of advice to a person who is looking for faculty job?
So you will find all these announcements pop up, apply to them all, every single one of them. I think when I was applying, I applied to every open position in the country. So
Even if you don't want to go there?
absolutely. My philosophy, so I kind of have a two-body problem. My wife is in academic administration, so it's a little bit
Okay.
different. She's not faculty, but we basically our philosophy was only turn an opportunity down once it's in front of you. Right.
Okay.
If somebody's offering you the job, then you can say no. Don't turn it down by not applying for it, even if you think it's weird. I applied for a lot of weird jobs, because oftentimes that may lead you to the next step that will be more promising. So especially if it takes multiple rounds of applying, oftentimes you'll find things, you'll talk to people, you'll make it. It's that networking, right? You make those connections, and just apply to it. Right?
Is there a reason you wanted to stay in Texas itself, or and how is it like being in a women's university? Like, is it like all women's? You get only students?
So I'm from this area. My parents live here, and that was a huge factor into. So part of it was my parents are here, my family's here, so raising kids, I wanted to be close to family.
Okay.
And then also because we live in the Dallas-Fort Worth area, there's a lot of other schools. So it was easier if I didn't find a position immediately, my wife didn't find a position immediately, there was more opportunities. We had a couple of interviews at other places where it was like, this is the only thing. It's a small university town and there's nothing outside of it for 100 miles or something. So, and then, the women's university, it's like I said, it's noticeably different. It's co-ed, so there are male and female students. The graduate student demographics tend to be a little more balanced.
Okay.
We have a lot of international students.
Then why is it called women's university?
So it was originally the state university, women's only state university.
Okay.
So like 1991, I think, is when they allowed to be co-ed. And to this day, it's I don't know, like 89% female. Okay. So it's still pretty heavily female.
Okay.
The undergraduate classes I teach mostly, I'll have 150 students and six male students. So it's still. Did
you have teaching experience prior to you did? Okay.
Yeah, I taught so I teach anatomy, physiology now, and I taught a lot of that in graduate school. Okay. I did not teach at all as a postdoc.
Okay.
But
go on.
I was going to say, I was often told, in terms of teaching experience, it's not as critical as research. If you're getting a 50-50 position, right? Because even with my experience, I had a sharp learning curve in terms of teaching the class and dealing with, tons of students and prepping.
Yeah, I don't have
basically prepping a 90-minute talk every week. So,
okay. Yeah. I don't have any teaching experience. So that's what I'm like, how bad is it?
Yeah, a lot of you'll have to teach, a lot of applications, you have to submit a teaching philosophy statement. And I'm like, I
haven't thought what philosophy do I have? Probably.
I've been teaching for a few years now, and I don't even really have a solid idea what that means. And that's something that I think your teaching ability comes through very well on a job talk, right? If you give a really solid job talk, if you give a great chalk talk, you can learn the material to teach to students. I think that was kind of what everybody told me, because I was always like, should I go adjunct somewhere and get teaching experience? Blah, blah, blah.
Like, don't care, just do your research.
Yeah, just get the research done. So
Okay.
that was there. I was like, as a postdoc, you're there to do research. Focus on the research. That was the advice.
Okay. Okay, thank you so much. Gopu, are you also interested in going into academic route?
I don't know. I'm just.
You're still thinking.
Now I still have papers to publish, so I'll think about it when I have to think about it way far down the line.
Okay. Yeah, but probably like, like a lot of people told me like you should have started developing some of these skills that you needed probably early on. I'm like, I didn't even know I wanted to be a PI for sure. So like
I mean, I work great with undergraduate kids. I mean,
okay.
I have a good rapport with them and all that, but then I don't know. Right now, I want to say I want to be in academia, but then you'll never know.
Okay.
Keep my options open.
Okay.
I don't know. It's like it's a Pandora box of questions, and you had to ask me this question, Aswathy.
And I have one more question for you. Do you
Yeah.
want to continue staying in US?
Well, now that I'm marrying an American,
Okay.
yeah,
Probably you have.
yeah. So yeah, the idea.
Okay.
Yeah.
Okay, great.
All right.
Okay. I have a lot more questions, but yeah, we are running out of time. But thank you so much.
All right, Aswathy, I'll see you around.
Thank you, Aswathy.
Thank you.
And good luck with
Bye-bye.
everything.
Thank
Yeah.
you so much. Thank you. Bye bye. All the best for both of you. Bye.